Today we're going to talk about how to read an element square. The first thing to know is that you can find all of the different element squares on the periodic table. But for today's lesson, we're just going to go ahead and break it down and look at one element square at a time. So, this first number at the top tells you your atomic number. The atomic number is really important for us because it tells us the number of protons and electrons. Because we work with neutral atoms, if we know the number of protons, we also know the number of electrons. This here in the center, this is called our element symbol. The element symbol is composed of 1 to 2 letters, and something that's really important about the symbol is that the first letter is always capital and the second is lowercase. And that'll come really in handy whenever we start looking at chemical formulas. So remember, the first letter is always capital and the second is lowercase. This next thing here underneath the element symbol is just the element name. Here at the bottom is the atomic mass, which is the mass of the atom. And remember, we've already learned that we weigh our atoms in AMU. Something that's really important here in 8th grade is that we use the atomic mass, but we always round it. I'm going to write this to the whole number. We round to the whole number for all of our atomic mass. So this is how it'll read on the periodic table. But if we have 6.9, we look at the number after the decimal, and we would round this to 7. If our number was 6.2, because this number is under 5, this number here would stay the same. That's just our general rounding rule. So we always round our mass to the whole number. So in this case, the atomic mass that we would be dealing with for lithium would be 7. And the atomic mass tells you the number of protons plus the number of neutrons. So we know that this number here, our atomic mass, tells us protons plus neutrons. This number up here tells us protons and electrons. If we were wanting to find the number of neutrons, all we would have to do is subtract. So here we know the number of protons from up here at the top of our element square. So we know there's 3 protons. Because there's 3 protons, there are also 3 electrons. Now, to find our neutrons, we need mass minus the atomic number, and that will give us neutrons. So sometimes we like to remember the word man when we're looking for neutrons. So in this case, it would be 7 minus 3, which would tell us there are 4 neutrons in an element of lithium. So once we know all of this information, we could draw our Bohr model. When we're drawing our Bohr model, remember, in the center of our atom is our nucleus, and our nucleus contains protons and neutrons. Here in an atom of lithium, we have 3 protons. In an atom of lithium, we have 4 neutrons. And then we have 3 electrons. If you remember from our last lesson, you can only have 2 electrons in this first ring. But we need a total of 3, so we would put the third in the second ring. And this would be a Bohr model based off of this element. Let's try it again. Let's look at an element called boron. So we know our atomic number tells us that boron has 5. Here, we're going to cross this one out. Now we're looking at boron. Boron has 5 protons. Because it has 5 protons, we know that it has 5 electrons. The atomic mass for boron is 10.81. The number after the decimal is above 5, so we would round this mass to 11. To find the number of neutrons, we take mass minus the atomic number, and that gives us our neutrons. Now let's draw the Bohr model of boron. We need 5 protons. To draw that, we put them in the nucleus with our plus signs. We need 6 neutrons. Those go here in the center with our protons. Then we need 5 electrons. Remember, only 2 in this first ring. We still need 3 more, so we can put them in our second ring. This is a Bohr model of boron. Let's try it again. Let's do carbon. Carbon has an atomic number of 6, which means 6 protons and electrons. Let's go ahead and write that in. 6 protons, so that tells us 6 electrons. Now we need to find the mass. The mass of carbon is 12.011. We look at the number right after the decimal. It is less than 5, so our mass stays 12. To find neutrons, we do mass minus the atomic number. That means carbon has 6 neutrons. Let's go ahead and make the Bohr model of carbon. We have 6 protons, 1, 2, 3, 4, 5, 6. And 6 neutrons, 1, 2, 3, 4, 5, 6. Then we have 6 electrons. Only 2 in the first ring. We still need 4. And we can put those in the second ring. Here we have our Bohr model of carbon. Let's do just one more. Let's do a little bit of a bigger one. This is neon. Neon has an atomic number of 10, which tells us that we have 10 protons. Because we have 10 protons, we also know we have 10 electrons. To find the neutrons, we take our mass, which is 20.180. The number after the decimal is less than 5, so our mass remains 20. We subtract the atomic number, and that leaves us with 10 neutrons. Let's go ahead and draw that Bohr model. We have 10 protons, so we need 10 plus signs. Then we have 10 neutrons, so we need to go ahead and add 10 neutrons. Now we have 10 electrons. So 2 in this first ring. We still need 8 more. And remember, our second ring can hold 8. So we're going to put all 8 inside this second ring. And that's a Bohr model of neon. We're going to do a little bit more practice next. If you need a refresher, come on back to this video and re-watch it.